Welcome. Welcome to Introduction to the IoT in the Cloud. I am very pleased today to talk about IoT and AWS IoT, what we've done this year, and have with me a great customer, Amway, to talk about their story. What you should expect from that session is to get a little bit of an overview of AWS IoT Service, for those of you who haven't seen it this year, and really look at all the new features that came out throughout the year, especially around the console, the operational analytics, and the security features that we released. And the second half of that session is about Amway. It's going to talk about how they transform their company into a connected company, coming up with their first connected air filter. We're at the very beginning of a massive disruption. The disruption is coming through customers like Ratio, who have saved millions and billions of gallons of water by connecting sprinklers in consumer homes. If you believe that the internet has changed the world, or you believe that mobile and social networks have changed the world, you got to get ready for an order of magnitude bigger with IoT. The change is really driven by how data is generated. We're moving from a world of human-generated data. Think about how many times you go see your doctor, maybe once or twice a year. They get your blood pressure, your heart rate, your height, your weight. It's pretty spotty. How many times you go see your car manufacturer because your car has a problem? Maybe not even once a year. How many times do you talk to your insurance about how you drive? Do you call them every day and say, I drove nicely today? Did they give you a discount? No, that doesn't work that way. It's a very sporadic interaction with the world, and that gives you a very partial view of the world. And that's changing now into machine-generated data. And machine-generated data is continuous. That means that when your car is in the garage, it could actually say, I'm in the garage all the time. When it moves, it's going to say where it moves, how it moves, the RPMs, the vibration, the temperature, the levels. And you get a full view of what's going on with that car. So the machine-generated data gives you perfect insight of what's going on and opens up the door for new insights on the data that's generated. But it is just the beginning. And at every beginning, you need very strong foundation to build upon. And we think that those foundations are built on three major pillars. Simplicity. IoT is all about hardware, connectivity, cloud, software, all colliding in one unified offering for your customers. And the problem is the skill set of all those people that are working in those different areas are different. The embedded guys don't really understand how the cloud works. The cloud guys don't really understand the embedded world. And in between, you have those connectivity people. It's kind of strange. And it has to all come together. Albert Einstein had a good saying, said, everything needs to be as simple as it can be, but not simpler. It's not because it's simple that it's not powerful. So we have to keep that in mind. Scale is the second pillar. With that amount of data that's generated, you need a lot of scalability, flexibility, and that's what the cloud brings to the table for IoT. And number three is security. And it's not because it's the third pillar that it's not the most important. I actually believe that security is the most important for IoT. We're going to talk a little bit about that during that session. Last year at reInvent, if you were there, we announced a service called AWS IoT. And I won't spend too much time on the actual service because there's a lot of information on our website already. But I'll tell you a little bit of what it is. It's an all-in-one service. That means that as part of the AWS IoT service, you get a message broker. It's a pub-sub broker. It does MQTT, HTTPS, and WebSockets. You have a rule engine that can bring context to the data generated by your devices, either through an Amazon machine learning model, bring a prediction back, either through a request to the shadow service, which is the virtual representation of your device, and know what state it was in last time you checked, either through other means of DynamoDB tables or other means to bring context, does some transformation, has some math capabilities, can bring timestamps, things like that to the data. And then the rule engine will pass down that data to other AWS services We have 10 of them today, including Lambda, Kinesis, DynamoDB, but also S3, SNS, CloudWatch, Elasticsearch. Pretty cool if you want to use Kibana. All those services are natively integrated in the rule engine, and the data can be passed down. It can also republish in another topic to trigger another rule. We have a shadow service as part of that AWS IoT service. The shadow service is a virtual representation of your device in the cloud. That's very handy for several purposes. The first thing, it holds the state of your device. What's the last known temperature? What's the last known position? What's the last known whatever attribute you want to put in that shadow? And that allows you to query those states without talking to the device, saving battery, saving bandwidth, being faster. The rule engine starts querying the shadow all the time. You don't want that to go on the device itself. The shadow service also serves another purpose. It gives REST APIs to your developers to talk to the device. That's handy because first, the mobile developers or web developers really know REST really well. It's pretty easy. They don't know how to talk to the devices. And a lot of devices don't really have REST APIs at all. So it makes it very easy to build application on top of your devices without knowing really if it's talking MQTT, if it has REST APIs, if it can talk, if it's connected, if it's not connected. Doesn't really matter. You build on the shadow will take care of the communication back to the device. And finally, we have a registry service. The registry service allows you to create your device, declare the attributes, serial number, owner, whatever you want to put in there. You can put up to 50 attributes in your registry. And you can also create thing types, which are templates of things which have a set of attributes that are common to all the things that are associated to that type. I'm going to add more feature to that registry. It's going to start being pretty powerful. And the service comes with a very simple pricing. It's a price per message. It's actually $5 per million messages. And you have to remember, when you pay the per message price, you're not paying just the message. You're paying for the rule engine execution, the shadow storage, the shadow access, the registry storage, the security, and all those services as part of that price per message. We have enterprise discounts. It's not publicly on the website, but if you have fairly large amount of volume, you can work with your account executive to get some discounts on that $5 per message. So don't hesitate to ask. What's interesting about AWS IoT is that it's a managed service. When you go in your AWS console, you will see an icon. It's called AWS IoT. Just click on it. It's there. You don't have to install it. There's no sharding to create. There's no auto-scaling to configure. There's no redundancy to configure. There's no pre-provisioning of resources. It's all there for you as part of the managed service. It's really a pay-as-you-go model. Even if you have 10 million devices declared in your registry and certificates in there, if you don't generate a message during a month, you will pay $0. You pay only for what you use. It's natively redundant across availability zone. It's natively scaling up and down. You really don't have to care about it. Just send data. If it's one device, a billion devices, it doesn't matter. It's the same endpoint for your account. Just pump the data in. So working with a lot of customers throughout this year, and after 13, 14 months of work with customers, we've been fairly amazed with the amount of use cases we've seen from consumer device, talking about ratio, to Philips that you just saw in healthcare, to mining, oil and gas, industrial, utility. We've seen use case all across the board. And based on those use cases, we've learned a lot. And we've increased our product with a lot of features, and that's what we call working backward from the customer. We talk to the customer, listen to their problems, listen to their needs, and then we work backward from there to actually add features to the service. We're not trying to build faster horses there. We're trying to bring innovation to solve customer problem. And that process has led to a lot of innovation this year, and kind of talking to our pace of innovation. This is some of the major features that we released on the AWS IoT service. I talked about MQTT or WebSockets. That was in January. We added IPv6 at the time support. We added the integration with Amazon Elasticsearch and machine learning. We added some security feature like bring your own certificate and just-in-time registration, which I'll talk a little bit more about. The support for binary payload. If you have encrypted payloads, for example, we can pump that into the rule engine, pass it up to Lambda, and then process that encrypted payload. And new last week, the new console, IoT at the edge. If you were at the previous session, you've seen a lot about Greengrass. How do you do Lambda execution on the edge, on the device, or on the gateway? Have security, state synchronization, and authentication at the edge through Greengrass. And we have new operational dashboards as part of the console natively. The console was a very interesting project we had to work with customers, because I have to admit the first version of the console wasn't that great. So we reworked it completely, did a lot of user research, a lot of user testing, and one of the first things you will see when you get to the new console is how do you connect your first device to AWS IoT? How do you test it out? We added a little onboarding wizard. That wizard is super easy. There's 3 windows. What do you want to do? Do you want to connect a device? Do you want to connect a mobile app? A web app? It's a little different. Web app would be JavaScript. Mobile app would be iOS or Android, most likely. A device may be a little bit different. When you choose, for example, to connect a device, we'll tell you, OK, we're going to create a device in the registry. We're going to configure your connectivity. We'll let you download that, and we'll help you connect the device. So here you would click and say, OK, I have a device. It's a Linux device. I want to do Python, whatever. The next thing is give me the name of your device. So in this example, my thing. Great. Next step. Based on that, we'll create the thing, create the certificate, create the policy, create all the keys you need. We'll package that up in a little downloadable file. We'll have in that downloadable file a script that you can run for the OS you chose, if it was a Linux, for example. Download it, put it on your device. We tell you how to unzip it, run, and then we'll just wait. And what we'll wait, the script will run, connect to AWS IoT, and start sending data. And that's what we'll see in that same window. So we'll just wait and see if it works. That should take you about 10 minutes. It's about 9-time improvement from the previous console. It's pretty good improvement there. So I really encourage you to test it out. Once you're done with that, we're really helping you, go further in the console. So it's more hand-holding to get you going with AWS IoT. Be reassured you have 250,000 messages per month for free for the first 12 months. So that's not going to cost you anything. That new console has been redesigned through a clearer navigation. All the objects in the previous console were in the same place. Certificates, things, rules, everything was in the same place. It was very confusing. We split them up. We now have a dashboard section, a connect section, that's where you find the wizard, a registry, security to configure, bring your own certificate, configure your certificates, configure your policies, etc., a rule, and a test, which is an MQTT client directly in the console that you can use to debug, trace, and play a little bit with the traffic coming in. Let's talk about the operational dashboards. I insist on the word operational. They're not analytics. They're not too much about the data. It's more about the platform. How is it working? Number of connection success. Number of protocol use. Distribution of those protocols. Is the traffic in and out? How much do you get in and out? How much messages are published? How much rules are executed? That's kind of an overall dashboard for the platform. And then you can drill into more data about the things themselves. The lifecycle events, the connect, disconnect, the publish, the subscribes, the directions of the message from things, which is different from the shadows, for example. And you can also create custom metrics. Now I have the ability to create custom metrics to say, I want to track the temperature of those things. You just create that custom metric, it's a new rule, and then that custom metric will start showing up in the dashboard, like it's shown in that example. You can also go deeper and track at the certificate level and get insights about authentication failures or authorization failures at the certificate level. So you can drill down pretty quickly and be fairly deep into what's going on in your platform. It is the first foray into analytics inside the console. You'll see more coming out throughout the year, but this is the first start of it. So let's talk about security. As you know, you probably heard in October, the DIN Inc. attack was kind of a wake-up call for a lot of people. we realized that IoT devices could actually be part of an attack and do some severe damage. Unfortunately, those devices were IP-enabled cameras with default login and password open to the internet. That's pretty easy to hack if you think about it. So we're really trying to help people build secure IoT devices. And at AWS, because we put security as a #1 priority, we put the bar pretty high. We're actually forcing you to use X509 certificates and TLS 1.2 for authentication and encryption of the traffic coming up from your devices. And a lot of people are thinking in the room, oh my gosh, certificates. How do I do that? I have to manage my CA, I have to manage my keys. How do I work with that? How do I secure that? The answer to those questions is not to lower the security bar. The answer to those questions is, how can we bring features to the table that will help you get there more easily with more simplicity? And those are the features that we released this year to help you in that journey. At the very beginning, you could only get certificates from AWS IoT. You had to generate them in the console. First thing we kind of said, that when you authenticate through HTTP to do your REST calls, you don't really need a certificate. You use SigV4. That's what you use for every services at AWS. Very secure way to connect. We enabled you to bring your own CSR. That's a certificate signing request. And we would sign it on your behalf, so we don't have to generate the private keys. You can generate them on your devices. We released Bring Your Own Certificate. And that's really to allow you to use your own certificate. You upload your CS cert to your AWS IoT account. And every certificate that is signed by that CA, you can upload that, and we'll validate that for authentication. So you don't have to use ours anymore. But now you're wondering, do I have to upload all those certificates that I generate in advance? Well, that was the problem, yes, with Bring Your Own Certificate. So we released just-in-time registration. Just-in-time registration is an extension of Bring Your Own Certificate, which allows you, same way, to upload your CS cert. But then you don't have to upload all the device's certificates in advance. When the device wakes up and presents its certificate, we'll validate against the CA that's there, and we'll say, oh, that's actually yours. We'll create the certificate in your account and let the device in. That's super useful for migration. If you have a bunch of devices that have their own certificate and you want to migrate them to AWS IoT, you don't have to go on each device and get the certificate out and put it in your AWS IoT account. You can just let your device ping your service, and will auto-register just in time when it's showing up. That also avoids having a lot of certificates that you don't really need in your account. That's been used by Amway, so they'll talk a little in more details about that feature. We added support for ECC. We had RSA at the beginning. We added support for ECC with forward secrecy. We have 18 TLS Cipher Suite support. We added policy-based access, because it's not because you're authenticated that you have access to everything. Authentication is one thing, access policy is another one. Policies until now, actually this is fairly recent, it's about 2 weeks old, you had to define the policy per device. And in large deployments, like we have for some of our customers, it was becoming really a problem. So we released dynamic variable in the policy that can allow you to have one policy, apply that to all the devices, but have that granularity. For example, using the device ID as one of the variable. If you use device ID as a variable, you could say that device can only publish on the topic of that device ID and subscribe to the topic of that device ID. With one policy, 10 million devices, you have that granularity. Makes it super easy for large deployments. And the role-based action is about the rules engine action to really control what a rule can post or can do in your AWS infrastructure. The rules run in the context of your account, and you have to give permission to those rules to actually post in your Elasticsearch cluster or your S3 bucket or execute certain Lambda functions. And one last thing we've done is work with Microchip and Atmel initially, before it was acquired, on a crypto chip. And that crypto chip is called ECC 508. It's a very tiny chip. It's 3 by 2 millimeters, super small. It's 50 cents. It's pretty cheap. In low volume, in high volume, it's cheaper. What Atmel and Microchip have done is work with AWS to make sure that if you want to use that crypto, they can actually pre-program the crypto for you in their secure manufacturing line with your certificate to make sure that that crypto, when it comes out of the manufacturing line, has a unique certificate per device that will be compatible with the authentication mechanism of AWS IoT. That makes it really easy to add encryption, security, and access to AWS IoT for a simple 50 cents bomb. So there is no excuse to not secure your devices. Don't be part of that DNing attack or the next one that's going to come. Work with Atmail and Microchip if you want to. We've tried to really turn that problem of managing certificates and putting them on the device into a simple bomb that you have to add to your device and bring you the highest level of security. So in those words, I want to give more time to Amway. I've got Everett and Mike here. That are going to talk about their journey to a connected company. They've used a lot of the features that I talked about. They use just-in-time registration. They use the crypto. They use AWS IoT Service, per se. And they're going to talk to us about their journey as a company toward achieving one of that device here. Unfortunately, the Wi-Fi is really flaky. So we're going to show you what they have here, but not really go into a deep demo, apparently. So that's what it is. Everett, thank you.
All right, thanks. So before we get started, I'd like to kind of talk about who is Amway, who are we. I'm Everett Binger. I've been at Amway for 12 years, actually. I've actually done about 6 years of solution architecture at Amway. This is my good friend, Mike Gartner, also colleague. He's been at Amway for 5 years, but 12 years of actual platform architecture experience. So who is Amway? Amway is actually the #1 direct selling company in the world. We operate in about 100 different countries and regions, so we're fairly large from a global footprint perspective. We have 450 products that all have a 100% satisfaction guarantee with those products. And we're in 71 million homes, so you probably have used an Amway product and you don't even know it. Most people probably have used Amway products. We have approximately 19,000 employees globally. They're kind of distributed. So that does cause some complications, especially when you're trying to implement something like IoT. And I'll kind of explain why that does add complications in a bit. And 70% of our top 10 markets actually grew last year. So we're definitely on a positive growth curve as well. So why would a direct selling company try and attempt IoT? I actually love this quote from Gartner. In 2016, 5.5 million devices will be connected to the internet every single day. For us, we really feel like the durable, the connected product, that the digital experience is actually just an extension of that product. There's no more digital experience trying to sell products. Our product actually has a digital experience, an extension of that. And we feel at this point, IoT is really table stakes. If you're not doing IoT, we feel like that's actually a value that you're losing potentially. There's a lot of value in doing IoT. It's table stakes. It's the cost of doing business at this point. You have to really understand what value propositions you can get from IoT, but it's essentially table stakes at this point. So how does Amway actually generate or create value? We like to call that value transition one, the many, and the all. So getting value across the entire ecosystem. Before I get too detailed in this slide, I kind of want to talk about what Amway is, their business model, so to kind of explain it a little bit. You can think of Amway very similar to a car dealership, like Ford. So Ford would manufacture a car. There's the Ford manufacturing facilities. There's Ford, the parent company. They would give those cars to dealerships. We call those dealerships ABOs, or Amway Business Owners. And then those dealerships would sell that car to a consumer. So we have a very similar model to a car dealership where we have Amway, the parent company, us, manufacturing goods, setting marketing materials, setting strategic direction. And then we have our ABOs actually selling our product for us to consumers. So how do we get value and generate value across those three different streams? For the consumer, it's all about personalization and data. We focus heavily on offering a very personalized experience, and we can do a much better personalized experience once we understand what data that consumer is actually using with the product. We also noticed that our consumers are extremely intelligent, maybe a bit too intelligent sometimes. So they're utilizing our products, they're expanding our products in ways we actually never thought were possible. So offering IoT, we can at least now know how they're using our products and how they're generating value for themselves in ways we didn't actually think were possible. How do we generate value for our ABO, for our dealerships? IoT gives us that data to offer personalization. It gives us the ability to create tools, selling tools, manufacturing tools that offer the ABO a much more detailed view into the consumers they're selling their products to. So IoT really does generate the ability for us to create these tools to really enhance the selling experience for our ABOs. And then how does Amway, the parent company, how do we gain value? Most of our value is once again in gathering data and offering personalized experiences for our ABOs and for our consumers. But a secondary, or maybe even a primary, depends on how you look at it, value proposition is actually gathering data about the products and making our products better. So one huge advantage of IoT is that we are collecting massive quantities of information about our products that we never had before. Our research and development departments, our product development departments are now getting information about our top-of-the-line products that, in all honesty, they probably didn't know how they were functioning in the past. It's very difficult to gather data using your traditional processes. IoT offers a facility for gathering that data in a much more seamless way. So how do we do this? How does Amway take on the IoT approach, and how do we tackle this new disruption in the industry? For us, we thought of it as adding a brand new business capability to our capability catalog. This is not something that was already a capability of Amway. It's not something that we had in our portfolio. We just needed to strap on a few more enterprise systems and then allow us to do IoT seamlessly. So we really did take the approach of thinking that IoT wasn't only a disruption to Amway, but also a disruption to the industry, and it's a brand new business capability because of that. A lot of this started actually as a grassroots organization. So we get this question all the time on, was IoT kind of executive down or pushed down through the organization? And the answer is no. It really was a grassroots organization. We had assembled a group of very tech-savvy, intelligent individuals across the organization, from IT, brand, digital, marketing, sales, product development, research and development. This group of individuals would meet quite often. We talk about technology, talk about new ways of doing things, and we actually created this grassroots organization, came up with IoT and presented that to executive staff. Some of those individuals are actually in the audience. We've got David Barman, who's actually our digital product owner, and then Jeff Tucker, somewhere out there, is our software developer. So kind of getting these different individuals together to really present and inform our executive staff on what IoT could be. Our organization was also not really set up to facilitate IoT that well. Probably very similar to most companies out here in the audience, but we were vertically, the value chain was more vertically aligned than horizontally aligned. So there were objectives, there were goals, there was a mission each year for each department individually to achieve. We had brand, they would have a set of goals, a set of operations they wanted to achieve. Digital had a set of goals they wanted to achieve. IT even had a set of goals that they wanted to achieve. Sometimes those goals did kind of blend across the organization, but in all honesty, not very seamlessly. Sometimes a brand or digital objective, IT would have no idea that that objective existed, but yet we'd have deliverables in the next year to achieve that objective. So it's a very much a siloed or vertical value chain at Amway. IoT doesn't allow that to happen. You're no longer allowed to have these siloed value propositions. You have to have a horizontal value. Like I said earlier, the digital experience is now just an extension of the product. It's not a separate thing anymore. So that value is now horizontally going throughout your organization. I actually love this quote, and I don't know who said it. I don't think it was me. It might have been you. But a connected device requires a connected organization. That is 100% accurate. You cannot have connectivity of a product unless you connect your organization first. So what does a connected organization really look like? Normally, a capability, a new product, it would go through a very traditional waterfall type process. We in IT used a SDLC, a software development lifecycle process, but each individual department also had their own sets of processes, own sets of documentation. So if an idea for a new product came up in research and development, they would document it, define it, put together a process or some type of business case for that product. They would then pass that product to product development. Product development would fill out all their documents. They would go through their process, determine what they wanted to do, pass that to brand. Brand would then take that product, go through their processes, really determine what they wanted to do, pass that on to digital, and then digital onto IT. So you can see that by the time digital and IT were involved, by the time some of the downstream departments were involved, it had already gone through several iterations, several approvals, and even a vast majority of definition of what the product was going to be. With IoT, we knew that IoT, because of the connectivity to our customer, because of the closest to our customer, it really required more agility. We had to take that very waterfall process and add more agility into that process. So instead of having a single objective for a product to go from one team to the next team to the next team, we really required that overall value, that overall objective was across multiple teams. We also tried to inject agility or agile into every area of the connected product ecosystem. So we have agility in our hardware development, agility in our firmware development, agility in our platform development, and in our digital experiences, like our mobile applications, websites, and so on. We get this question a lot as well. How do you have agility or agile in hardware development? You're making a physical product. How can that be agile? It's very difficult. And sometimes, in some areas, almost impossible. We have some facilities. We do proof of concepts. We run beta runs of product. We have prototypes or proto builds, prototype boards that we run as well. Those help kind of facilitate some of that hardware iteration, to iterate on the hardware rapidly. But you have to get to a certain point where, in all honesty, hardware is going to be locked, and that locking mechanism for hardware forces it not to be agile anymore. So the best way to overcome that is to inject digital, inject IT, inject those downstream teams, those downstream team members, early on in your product development process. We're now involving digital and IT in product ideation for the first time, I think, ever at Amway, ever at that company. So it's a very much a different way of thinking. Even how I get the idea is how you go through ideation of your products as well. We also iterate on those different agile sprints every 2 weeks. So normally, some of you are probably transitioning to an agile process as well. You're going to iterate on your IT software every 2 weeks. We decided to iterate on our entire ecosystem every 2 weeks. We inject firmware. We have iterations on firmware. We inject digital applications, brand, marketing material. We iterate across the entire value stream every 2 weeks. So a presentation probably wouldn't be complete without having the words agile and empower team on a slide, so I've got that checkbox covered. We thought about our teams completely differently. The team actually provides the value. Normally, you would have an individual. You'd have a software developer. He'd be developing software, creating code. He's adding value to your product. We completely thought about this differently as well. The entire team provides value. You need a very diverse set of individuals on that team. So we have product teams that have a digital representation, IT representation, brand, marketing, sales. They are all on a dedicated product team. They each have their own individual skills, capabilities, maybe even experiences that allow the entire team to be successful, but they have their specific goal that they want to achieve. I love this picture of a pit crew. You've got a very diverse set of people. Their main goal is to have the fastest pit time of any other team. They have a goal. They want to have the fastest pit time. There's a tire change guy, a guy doing gas, maybe a guy cleaning the windows. They each have their specific job, but the overall goal is to have a fast pit time. What happens if the tire change guy sprains his ankle? Does the pit crew decide, okay, we're not going to do pit stops anymore, just have the car go around the track and hopefully we win? No, that's not how this works. We ended up having individuals that were normally not set up or had they maybe had the skills, but they didn't have the opportunity to do other areas of development. They now have that capability with having an empowered cross-functional team. So for the first time as well, we have product development resources or software developers doing each other's jobs. We have a digital representative who maybe does some branding or marketing materials because we have a very large quantity of marketing assets need to be created at this time. So a digital person can step in and really facilitate that role. So not only do you need a very cross-functional set of individuals, but that cross-functional set of individuals needs to have the capability to do any job on the team or a majority of those jobs on the team to a satisfactory level. It might not be the most efficient. Your product development resource might not be the most efficient person at writing code, but they can at least do it enough that you can hopefully add value to that sprint. So I just gave the marketing speech on how we do it. I'm going to have Mike actually show you really how we do it from a more technical perspective. So Mike, why don't you go ahead?
All right, thank you. Well, like Everett said, my name is Mike Gartner. I've been at Amway for about 4.5 years, and I just have to say, I remember reading a survey. This was a while ago, and I don't remember all the details of the survey. I just remember that there was a certain amount of people that they asked the question of, what is your number one fear? And the number one fear of these people that were surveyed was public speaking. And does anyone know what the number 2 fear was? Death. Whoever said that? I remember reading that the first time, and I just always thought that was ridiculous because, death, public speaking, but this room is enormous. So please bear with me as I try to walk through this. I have a bunch of technical data that I need to get through here in, I don't know how much time we have left, the next 10 minutes, I guess. So I'm going to talk briefly about our overall architecture, what we went through, some design considerations, some of the benefits that we saw with AWS as a whole, and kind of our first rendition of our IoT solution. So the role that I play at Amway currently is, in Agile terms, I'm the product owner of the platform, and I am the platform architect. The platform, by our definition, is all of the AWS components that make up the solution that all of our connected devices will attach to. So when I first started to integrate with the team or the IoT project, like Everett said, it was just starting up as kind of a grassroots initiative. It wasn't this huge executive sponsored project. So when I first started to integrate with them, it was kind of a small team, but they were in the process of doing vendor evaluation and vendor selection, putting together business requirements, what was going to be the best decision as far as a vendor for Amway's specific use case. There was a couple things that AWS, that we saw that AWS benefited. Some of the obvious ones are we saw a benefit as far as scale. IoT for us was a new business. And we really had no idea how much capacity we were going to need. Amway is a global company. We do, is it 100 companies or 100 different countries? So we do business all over the world. So we didn't want to have to invest in a bunch of infrastructure and global data centers all over the world. And we honestly just had no idea how big or how much scale we were going to need. AWS allowed, or the AWS services allowed us to not even have to think about that. So that one's pretty obvious, plus the global presence AWS has is also fairly obvious. Something that we also discovered is, in our estimation, AWS was a bit more mature in the IoT space as far as the services that they provided right from the start. So we figured that with the velocity that AWS had in rolling out new services, that this would be a good place for us to be. And then probably the number one factor of why where I think AWS has differentiated themselves in our estimation over the past 9, 10 months is their engagement model. They have really partnered with Amway to help come up with the solution to help deliver new features on their platform so we can take advantage of their velocity and we don't have to build all of the different features that we want. Their engagement model has been maybe the best of any different partner that we've had in the technology space. So, as we started to design this architecture, some design considerations that we had, one of the things that we knew we wanted to do is we wanted a microservices type architecture. Now, microservices is kind of a buzzword, and everybody knows that you want to move to a microservices architecture, and executives in particular, they don't like, monolith is bad, microservices is good, but we really had to define what that meant. And what does it mean to have a microservices architecture? What were the boundaries going to be of our deployment process? What was the impact going to be for us to roll out new features? And really, we wrestled with that for a while, but we wanted a microservices architecture. In order to help accomplish that, we built an entire CI/CD pipeline around the different components and features that we wanted to be able to deploy. We tested and evaluated several different frameworks. I've heard serverless thrown around. We worked with serverless for a while. In the end, we settled on building our own. And so we have the ability at this point to roll out new enhancements to any one of our features or roll out new features without impacting existing features. And each one of the components that we have, you kind of have to understand what the deployment method or model is, whether you have the ability to do a blue-green deployment or whether you don't have that ability, how you're going to do that. But the CI/CD pipeline has been a pretty big investment for us in this process and one of the major design considerations. Another one, as you can see in this architecture that we have, AWS IoT is one component of it, and you'll see, like Anthony talked, the various services that AWS IoT provides as far as shadow state, as far as message broker, as topics, rules engine, and all of that. But you need much more of the AWS services to have a fully functioning solution. So you can see we have AWS Lambda, we have Amazon DynamoDB, Kinesis, S3, EMR, we have Cognito, the API gateway is a big component, and then we have several more that we are in the process of developing today. So one of the things that we didn't set out to do this, but became apparent as something we wanted to take advantage of is that everything we have is serverless. That can be good, that can be bad. There are some challenges in deploying serverless components, but it did take some maintenance off of the table as far as not having to worry about IaaS components, EC2 instances, or any of that. And then one of the biggest considerations always coming up is security, like Anthony talked about. Amway did not want to be in the headlines for the wrong reason, and having our devices be the one that did that DDoS attack. So security was a major component. So we have policies like Anthony talked about. This isn't just a hard exterior and then a soft inside. Once you're in, you have access to everything. There are policies and security built throughout the entire architecture. So some of the features that we wanted to build, and what I'm going to do as I step through these features is just going to highlight the various components that we use. Command and control is basically the ability to send commands to our things so that the things can respond to those from anywhere in the world. I'm going to go through these quickly. Telemetry is what we call the data that we want to harvest from all of our things. So the telemetry data is harvested in this manner so that we can, data is probably one of the biggest business cases for embarking on an IoT project. And so this is the method in which we continually harvest that data and then transform it later for analysis or for analysis for use by the mobile application real time. Firmware update, this is also a big one. We didn't want to just develop a product and then send it out. Our Amway developed some of the world-class products that have 10, 15, 20-year lifespans. And so we couldn't have something that was going to be 20 years in the field and not have the ability to put new features on it. But firmware update also provides security challenges, and we needed to understand that we could deliver a firmware update in a manner that was secure and we could guarantee wasn't tampered with. Thing pairing is the ability to know that whoever owns the device is the only person who can control the device. It's the only person that can see the device's data. So this is also a security topic. And then just-in-time registration. This is a big one that we struggled with from the beginning. And I think that as we wrestled with this and as we talked through this with AWS engineers, there were many features that AWS implemented along the way that helped us, like bring your own CA. When we first started this, bring your own CA didn't exist. So just-in-time registration wasn't an option for us. So we were able to work and partner with AWS as well as Atmel's microchip to be able to implement in our things just-in-time registration. Now, for all of the technical people in the room, what I'm going to walk through here as detailed, I guess, as I can, is the just-in-time registration flow. So the problem is, from our standpoint, is we have a thing. We need to get it connected to the AWS platform. It has to, that communication, the requirement is TLS 1.2 with mutual authentication. So in order to have TLS 1.2 with mutual authentication, we have to have a device cert on the thing. Now, the device cert on the thing, if we need to have it secure and private, we have to have a private key on the thing that can never be exposed and can't be compromised in any way. We wrestled with this quite a bit. So with the Bring Your Own CA and the microchip, the ECC 508 module, we were able to put into our things, we were able to accomplish this. Now, the workflow that I'm going to walk through requires some pre-work in order to get this to work, and then I'm going to talk about the unboxing process for the customer. So the pre-work for the IT geeks in the room is the first thing you need to do is you need to create a root CA. Now, I guess you don't have to create one. You need a root CA that you're going to manage, and that's going to be owned by you. From that, we created a new root CA. From that root CA, you create intermediate CAs. Those intermediate CAs are what is going to be used by Atmel to actually create the device certificates on the ECC 508. So what happens is you ended up working with Atmel and through a process be able to securely exchange the intermediate CA certificates. These intermediate CA certificates Atmel loads into their secure manufacturing line so that they can generate private keys that get stored on this ECC 508. It gets stored in a manner that the private key can never be taken off of the chip. They create the CSR, they sign the CSR and store the device cert back on the chip at manufacturing, and that process never leaves the manufacturing line. Also, another feature of the ECC 508 was you can store other secrets on it. So we had a whole list of other secrets that we wanted to store on it. So we worked with Atmel to provide them the configuration, and then they load that at manufacturing, and it's never exposed publicly. So we're able to take that chip. We have the intermediate CAs that we gave to them. We take those intermediate CAs and we load them into our IoT or AWS account and under the Bring Your Own CA portion of the account. So now our account knows about those intermediate CAs, okay? And the device certs are already embedded in the thing. So the unboxing experience for the customer at this point is they order their new thing. They're really excited about it. It's really cool. They unbox it. They're going to take their mobile app and they're going to download, or their mobile device, they're going to download the app. Via Bluetooth, they're going to connect their thing to their local Wi-Fi. Okay, so that's pretty standard. Once the thing is connected to Wi-Fi, what will happen is without the user interacting or without the user kicking this off, the thing will attempt to make a connection to AWS IoT. Now these are some really cool, I spent a lot of time on these slide transitions, so I hope you enjoy them. So what happens is the thing makes a connection with IoT. IoT at this point does not know about the thing. It doesn't have the certificate loaded, so the first thing it does is deny the connection. However, the just-in-time registration portion recognizes this connection attempt. The thing, when it attempts to connect, it presents its device certificate as well as the intermediate CA certificate, the public certificate, to AWS IoT. AWS IoT recognizes that. It takes that certificate and it will load this certificate into the IoT registry under a pending activation state. So once that's done, now AWS IoT knows about the thing. It takes and it because it's using a certificate that we loaded in and it recognizes it, it validates all of that. And when it's a valid certificate, it will load it into the device registry, pending activation, and it will publish a message under this topic. Now what we have is we have a rule, an IoT rule, which is part of the AWS IoT platform that is listening on this topic. The rule kicks off an action which starts a Lambda function. The Lambda function does 3 different things for us. The first thing it does is it creates a basic IoT policy. This basic policy, in essence, only allows the thing to connect to AWS IoT. So we create a policy that says, yes, you can connect to us. We store some of this data in DynamoDB for easy retrieval later for some processing down the road. And then we go back and mark that certificate that was in pending activation as active. Now, behind the scenes, that process there is not even a second. So that is a very, very quick process. Now, what happens is while that's happening very quickly, the thing attempts to reconnect. Now, it might reconnect. I don't know. I actually don't know the timeout process, but it will attempt to reconnect. At this point, it's going to reconnect to a custom topic. I just put custom, and then it's a slash the hash. It's a SHA-256 hash of the certificate, and that's the topic name. We are listening also on that topic, which then kicks off another Lambda. At this point, we're going to store a bunch of data about the thing, metadata about the thing, in Amazon DynamoDB for processing and app usage later. We're going to create a much more robust IoT policy for this thing so that we know what it is. It's going to give it more rights to various things that we know that it's going to need to do later on down the road. It's going to create the shadow. It's going to populate the shadow with some various data that we're going to need to function. We have an entire contract, is what we call it, with what the shadow is going to look like, what it needs to look like for the firmware on the device to be able to respond to it. And I haven't talked about shadow and the relationship with shadow and the firmware on the thing, but the shadow is a very powerful component of AWS IoT. The next step is the Lambda is going to send a message to the custom topic under the accepted, and because the thing is subscribed to this topic, it's going to receive a message that has an entire list of topics that the thing is supposed to be listening on, that it's supposed to subscribe to. At this point, now, the user, all they've done is plug it in, connect it to Wi-Fi, the thing on its own, in a very secure manner, onboarded itself onto our IoT platform so that now we know what it is, it has the ability to connect. It was never exposed to compromise at any point during this process, and we can go through the process of pairing with it and allowing the user to command and control it. We can start harvesting data from it. We can start doing all of the things that people want to do with IoT devices. And that is, in some detail, the just-in-time registration process. I believe that there are other just-in-time registration sessions you can go to. There's 2 of them, Anthony's saying, that if you want to get much more detail about this process specifically. But this is what we've designed so far as our just-in-time registration. And so that's kind of an overview of our entire architecture. We have 6 minutes left. So I'm going to hand it back to Everett. We were planning on doing a demo. However, something's flaky with the Wi-Fi here. So I don't know that we'll be able to do a full demo.
Also, I don't know if demonstrating the just-in-time registration process, that takes less than a second, so that wouldn't have been a good demo either. We were going to try and demonstrate some of the remote control features, so after the device is actually onboarded, we can remote control it, we can see device status, dust level, those types of things with what we're calling our next generation air treatment system, which will launch sometime in the next year. We can see filter status as well as some air quality information. I don't think we're going to be able to do that just based on the lack of Wi-Fi. So, yeah. I don't know, Andy, if you want to come back up and maybe make some more points.
Thank you very much. You actually have a unit here. Maybe you want to show it to just so people can
Yes.
see what it looks like. In terms of sessions, there's a session at 2 p.m. about the just-in-time registration that's more technical. If that wasn't technical enough, you get one step deeper into the technique about just-in-time registration and how to use that crypto chip in other areas of AWS. That's a good session at 2 o'clock. And plenty of other IoT sessions. That's why you're at the Mirage this afternoon. So thank you very much, Mike. That was great. And I hope you enjoyed the session. Thank you.
Thank you.